So in this video we're going to perform partial fraction decomposition on this term here, 2 divided by s to the 4 minus 16. Now partial fraction decomposition on this means we've got to do something with our denominator. Well, here clearly s to the 4 minus 16 looks like the difference of two squares. So let's write that out. So we've got 2 over s to the 4, so that will then be s squared minus 4 squared. So that will be our difference of two squares. So therefore we can write this as 2 over s squared minus 4 and s squared plus 4. So that's our first look at breaking this apart. Now there's still more we can do with here by the looks of things, because s squared minus 4 I can factor out even more. For s squared minus 4, not much I can do with that unless I go into complex numbers, which is not suitable for this kind of question anyway. So I can now rewrite that as 2 over s squared minus 4. I'm going to put the s squared plus 4 first, as there's not much I can do with that at the moment. And then I've got s minus 2, s plus 2. Hence another difference of two squares again. Okay, now for partial fractions, what I would need to do now is break this apart into some separate building blocks for each term in the denominator. 2 over s squared plus 4, s minus 2, s plus 2. And then the building blocks from that we'll have. So first of all, s squared plus 4, that's a quadratic. So I need a linear term in my numerator. So we'll have as plus b, that's my linear term, and then my quadratic in the denominator. Then my next term, s minus 2. S minus 2 is a linear term, so I just need a coefficient in the in the denominator, and then the same with this one. So then I've got d s plus 2. Okay, now what do I do next from here? Well, the Heaviside cover-up method is not going to be suitable for this one, I would say. So corresponding coefficients is the way forward, I would say, from this one. So for that, my first step is to multiply both sides by this term here in the denominator. So if I put a bracket around this and write this over the other side, I've got s squared plus 4, s minus 2, s plus 2. So now I'll multiply both sides by this term here. So now I'm going to get, multiplying this with this, the denominator is going to cancel out and I'm going to be left with 2. So now 2 equals, and then multiplying this with each of these terms here. Now first of all, this one here with the quadratic denominator. Multiplying that by this, the s squared plus 4s are both going to cancel out, and now I'm going to be left with as plus b times s minus 2, s plus 2. Well, we know that is s squared minus 4. So I'm going to write that straight into this bit here to save me some time on my working. So that's that one. Now with this c term, I've got s minus 2, in which case that's going to cancel out, we're left with these two. So now I'm going to add c times s squared plus 4 and s plus 2. And then with this one, very similar to this one, except for the plus 2 will cancel out and I'll have a minus 2. So now I'm going to be left with d times s squared plus 4, s minus 2. Okay, now this is just now a case of just brute force and just multiply out all these things with my a, my b, c and my d. So let's go and take care of that. So now 2 equals as plus b times s squared minus 4. So that's going to give me as cubed minus 4as plus bs squared and minus 4b. So that takes care of that. This one here, before I distribute my c, I'm just going to FOIL this one out. So this is now going to give me s cubed plus 4s plus 2s squared plus 8. So now I'm going to be having here plus distributing c with all these. I'm going to have plus c s cubed plus c 4s, so that's going to be 4cs. So I'll write that like that. 2s squared times c, so that's going to be 2cs squared, and then add 8c. Okay, now same again with this one. Let's FOIL this one out before I distribute the d, and now I'm going to be left with s cubed minus 8 plus 4s and minus 2s squared. So I did that one in a slightly different pattern, but it doesn't matter. We got the same result anyway. So distribute this with the d. So plus ds cubed minus 8d plus 4ds and minus 2s squared. So just squeeze that one in the back there, and that's with a d. So it's minus 2d with the s squared. Okay, so now as we're doing corresponding coefficients, what I'm going to do now is to get my corresponding coefficients together with each of its corresponding ones for it. So s cubed, I've got an a, so let's write that out. So for s cubed, I've got a. Going further along, I've got a c, and there should be one more, so I've got plus d. And then for s squared, so I put brackets in that. So s squared, I've got a b. Same along here, I've got 2c. And there should be one more, so minus 2d. So that takes care of that. And then for my s, I've got minus 4a. Should be one here somewhere, plus 4c. And one more, plus 4d. And then my coefficients, so just without any s's, I've got minus 4b. So minus 4b. Here I've got plus 8c. Let's stick these on the bottom. And my last one would be minus 8d. Okay, so now let's match up to its corresponding value on the left hand side. So s cubed, there's no s cubes. So basically this here will become 0. So I've got a plus c plus d equals 0. That's the s squareds, s cubes. Now my s squareds, I've got b, c and d. So that means b plus 2c minus 2d will equal the coefficient of s squared. As there isn't one, then this will also equal 0. What about this one then? The s, I've got minus 4a plus 4c plus 4d. So minus 4a plus 4c plus 4d. The coefficient for s, again, there's no s term, so that is also 0. And then my last one, which is my constant, I've got minus 4b plus 8c minus 8d. So minus 4b plus 8c minus 8d. That equals, well this time I have a value, I've got 2. Okay, so that's my equations that I've got to try and solve. So 4 variables, 4 equations, so it's going to be possible to get some sort of solution. So I'm going to number these up accordingly. Okay, so now what I'm going to do is I'm going to leave my partial fraction decomposition set up and my equations that I've got, clear the board, and then we see if we can solve for a, b, c and d. Okay, now I've got my 4 equations here. Let's see if we can solve for a, b, c and d. Now you'll see here I've lined them up 1 and 2. They've got a, c and d variables, and 3 and 4 I've got b, c and d variables. So what I'm going to do is I'm going to try and match these up and see if we can do some sort of substitution. So equation 2 is minus 4a plus 4c plus 4d. Equation 1 is just with a plus c plus d. So if I multiply equation 1 by 4, that will give me something that I can work with to try and find something in there. So equation 1 times 4, that gives me 4a plus 4c plus 4d, which equals 0. And then just plugging in equation 2 next to it, I've got minus 4a plus 4c plus 4d, that will equal also 0. Now I've got 4c plus 4d on both, and here I've got a plus 4a and a minus 4a. So as these two terms here are the same in both equations, I've got something here with a plus 4a and a minus 4a, both yielding a 0. So unless a, c and d are all 0, then my a terms here must definitely be 0. But it's very unlikely that my c and my d will both be 0 because of this kind of a setup. So therefore I conclude my a is going to be 0. So a equals 0. So I'm going to take that as my first solution. So therefore these terms will then cancel out as a is 0. So that will go into there. So now I've got 4c plus 4d equals 0. So 4c plus 4d equals 0. Move the d onto the other side. I've got 4c equals minus 4d. Divide both sides by 4. I've got c equals minus d. Now that could be useful for some kind of substitution when I go into this one. So that's what I'm going to use in my next setup. So c equals minus d. It's not a solution, but it's going to help me with the next bit. Okay, let's take this off the board and have a go with equations 3 and 4. So equations 3 and 4, I've got 4b, 8c and 8d with some terms here, and b plus 2c plus 2 or minus 2d here. Now again, if equation 3 I multiply by 4, I'll have similar coefficients even if the signs are different. So it's going to give me something to work with. So equation 3 times 4, that's going to give me 4b plus 8c minus 8d equals 0. And then I just put equation 4 next to it. So I've got minus 4b plus 8c minus 8d, that equals 2. Okay, now what I can do is, maybe I can plug in a value for my c or my d into here to make one of these go away. Then I'm going to be left with two variables which I can solve with a simultaneous equation. So let's do that. So minus d is the same as c. So let's plug that in for both of these. So now this one would now be 4b plus 8c, and then minus 8d. Well, c is minus d, so this is going to be 8c. And that equals 0, which now simplifies to 4b plus 16c equals 0. Now let's do the same with this one. So minus d is the same as c, so this one would be minus 4b plus 16c. So that would be the same in this circumstance. So let's put that in there. So now I've got minus 4b plus 16c equals 2. So now I've got something I can work with here. I can add these together, and then my b's will cancel out and I'm left with the c on its own. So add them together, these will cancel out, and then I'll be left with 32c equals 2. So from that, c will equal 2 over 32, which is 1 over 16. So therefore c is 1 over 16. So that is a solution for c. Now I've also got c equals negative d. So therefore d will equal negative 1 over 16. So we can write that in there straight away from what we found in the first set of equations. So that would take care of that. Now with that, if I've got c, d and my a is 0, well, I've got b here as the only missing value for this equation. So if I take equation 3, and that is b plus 2c minus 2d equals 0. I know c is 1 over 16, so I've got b plus 2 over 16 minus d, which is minus 1 over 16, so minus 2 over 16, that equals 0. Well, 2 over 16 minus 2 over 16, that's going to now simplify to b plus 4 over 16, which we know is a quarter. That equals 0. So with this here now, I can say that b must be minus 4 over 16, hence minus a quarter. So therefore b equals minus a quarter. Okay, let's take this off the board and rewrite our partial fraction decomposition in its complete form. Okay, so let's rewrite this with these coefficients. So then that equals a is 0, so that term disappears, but b is minus a quarter. So I've got minus 1 over 4 times s squared plus 4. Here I've got c, which is 1 over 16. So I've now got 1 over 16 s minus 2. And here d is minus 1 over 16. So now I've got minus 1 over 16 s plus 2. Okay, so that is my partial fraction decomposition completed. Okay.